Hi, in this video we will be performing the analysis regarding fitting of AI-based neural network algorithms in RStudio, and for that we'll be using a data set which consists of three different variables: height, diameter and volume will be our target variable. And in order to perform such kind of analysis, especially neural networks, for that we need to recall certain kind of libraries like neural net, caret and matrices, which is very much important as far as the selection criteria are concerned. And caret is required usually for cross validation and so many other procedure. Tidyverse is a collection of so many libraries, and neural network is this neural net is a very important library for fitting of these neural network algorithms. Once we have recalled these kind of libraries, then the first important step for fitting of any neural network is to do the data standardization or normalization. We can use the minimum maximum score for that, or we can use the standard normal variate procedure. So this is very important since we'll be having a different variables, and all the variables might not be measured on the same unit. They might be having different kind of units. So in order to put them on a common scale, we used to have to apply this kind of a procedure, which is known as standardization. Once we have done the data standardization, the next important step is to apply the cross validation technique, where we have to randomly partition the data into training set and the remaining into the testing set. Then after cross validation, the next important step is to fit this neural network algorithm on the trained set. Then we have to find out how many hidden layers we have to choose, since this neural network consists of three important layers. One is input layer, then we have hidden layer where all these iterations and all these magic takes place, and where the activation function plays a very important role. And we have a third layer which is known as output layer. Since hidden layer is very important, and in traditional neural networks we used to have only two hidden layers, but the question here is how many number of neurons we can choose within a hidden layer. So that combination has to be done manually. Then we have to apply the number of repetitions, since it is an iterative process. Then we have to fix this value, and this is activation function, which is the important essence of this neural network. Whether our problem is regression, whether our problem is classification, accordingly we have to apply logistic, sigmoid or any other activation function. Then we have to choose the threshold value, since it is again an iterative process. Then we have to choose if the change in error is less than 1%, then no further iteration can be done. So all these combinations we have to apply, and we have to execute all these kinds of functions or codes. And finally, in order to test the reliability in terms of the selection criteria, then we have to apply another course, and we have to write another more course for that. Since this is a very cumbersome process and we have to write so many codes for that, in order to overcome such kind of coding, which requires a lot of time, and sometimes it becomes very hectic, and sometimes we are having a very limited time, then we have to perform the analysis in a very quicker time or a short duration. For that we have a solution. We have a library which is available in R, which is known as ImNN. Okay, this is a library. Here it is. The description of this library is here. It is used for neural networks for predicting volume of forest trees, and the arguments are here. It has got a default data set which is here, this one. Okay, then it uses a combination of hidden neurons. The number of hidden neurons in neural, it actually by default there are only two layers in these in this library. It utilizes a neural network. It fits a neural network which consists of two layers. Only we have to give the option of how many neurons within a layer we can use. Since in order to choose the number of neurons within the hidden layers, for that we have a formula which is given by Shi and Zhang. You can Google it out, 2012. We can use this formula, where any value within the range of 1 to 10 it can be used. Now it depends upon how many inputs you have in your layer, in your algorithm or your data. and what is your response variable. You are having a single like a regression problem, or you have a classification problem. But the important thing is that this library is a savior in a way that we don't need to write all these kinds of codes. For that, what we have to do, we will simply write, say for example, anything, like we will write model, then followed by assignment operator, or is equal to, then we have to write the default function name, that is ImNN, followed by the name of this data set, which is VOL. Then we have to set the range of our neurons within the hidden layer. Suppose if I will write 2 here, then I will press enter. Then we have to wait for few seconds, since it will take 2 iterations for that. Then you can see here, first it utilizes our automatic threshold of 0 point, and we have a neural network plot also. And the first important thing is that we have a threshold value of 0.01, and the total number of repetitions are 2. The number of steps for the first repetition is 14456, and the error which has occurred, or we can say the error in this, it is 0.05, and it takes a time of 6.3 seconds. Here you can see we have 2 inputs, height and diameter, and within these input and output layer we have 2 hidden layers, and every hidden layer consists of 2 neurons here. So we have a choice here. We have to only set the values of neurons, and we have 2 NN plots, which are very important since these circles, they are known as neurons, and these lines, these arrows in black arrows, and they have some numeric values, and these are weights, and these blue circles or blue values, you can see these are known as biases in case of neural network. And these weights are similar to the regression coefficients that we have in traditional or conventional regression equation, and they are similar to those intercepts. Since we have set only the value of number of neurons, we don't need to set any kind of a combination regarding the number of hidden layers, because for a traditional neural network, maximum we can use 2 number of hidden layers, because if we use more than 2, then we are moving towards the deep learning. Then if we will write only model, then press enter, you can see the hidden neurons in layer first are 2, like this. Then the hidden layers in layer 2, hidden neurons in layer are 2. Then we have the results for R square, we have the results for this root mean square, we have the results for mean absolute error, and we have the results for prediction error rate. So we can use any combination of the number of neurons. Say for example, we want different kind of number of neurons in first layer. Simply we have to choose here the value. We will simply write here C, the concatenation function, like in this way. We can simply write C, then followed by 2, 3. It means in first hidden layer we want only 2 number of neurons, and in second hidden layer we can use we want only 3 number of neurons. For that you can use these kind of combination, and within one click you can get all the results. So this video is highly recommended to those people who are interested to perform the neural network or the fitting of the neural network utilizing this kind of a data set, where you have 2 important variables which are used as explanatory variable like height and diameter, and based on this you want to predict, or you want to accurately estimate the volume in terms of neural network. For them it is highly recommended. Simply you don't need to do anything, you simply need to write the default function, then the name of the data set, followed by the number of hidden neurons range. That means you have to set the range of the neurons within that hidden layer. Hope this video will be quite helpful, and you will learn something from this video. Thank you very much.